Okay, just take a look at your phone for a second. Now think about your car, or even the walls of the building you're in. Have you ever really stopped to think about where all the stuff to make these things comes from? Well, the answer is hidden deep inside the Earth, in this incredible world of minerals and energy. So let's dig in and uncover that story together. You know, to really get a grip on how important minerals are, you don't have to look very far at all. Seriously, from the tiniest little pin holding your clothes together to those giant skyscrapers that define a city's skyline, minerals are the invisible backbone of our everyday lives. All right, here's a little riddle for you. What on earth do your toothpaste, your car, and the food you eat all have in common? I mean, they seem like totally different things, right? But believe it or not, there's a surprising link.
The answer is just one word: minerals. They're like this invisible thread weaving through almost everything we do, the secret ingredient in our whole daily routine.
Let's just break down something as simple as toothpaste. You know the gritty stuff that actually scrubs your teeth? Well, that's silica and limestone. The fluoride that helps provide cavities, that comes from a mineral called fluorite. And that bright white color, that's titanium oxide. Even the sparkle comes from mica. And get this, the plastic tube and the brush, they come from petroleum, which is an energy mineral. It's wild. So we've basically found an entire geology lesson sitting in our bathroom cabinet. But what is a mineral, really? What does that word even mean? Let's get a little scientific for a minute. So geologists have a pretty specific definition. It's a homogeneous, naturally occurring substance with a definable internal structure. And I know that sounds a little academic, but what it really covers is this incredible range of stuff, from talc, which is so soft you can scratch it with your fingernail, all the way to the hardest thing on the planet, a diamond. Now, all these thousands of minerals, we basically sort them into three big buckets. First up, you've got your metallic minerals. Think iron, copper, the things that are great at conducting heat and electricity. Then there are the non-metallic minerals, like limestone and mica, that have all sorts of other uses. And finally, you have the energy minerals, the fossil fuels like coal and petroleum that power pretty much everything. Okay, so how do these things even form in the first place? How do they get all concentrated so we can actually find them? Well, one way is when hot, molten stuff gets squeezed into cracks and rocks and then cools down, creating what we call veins. Other times, they just settle down in layers over millions of years. Bauxite, which gives us aluminum, is actually just the weathered leftovers of other rocks. And sometimes rivers do all the work, washing away light stuff and leaving heavy minerals like gold behind in what we call alluvial deposits. All right, so that's the theory. Let's see how this actually looks on the ground. We're going to zoom in on India as a case study to really understand how these resources are spread out, or not spread out, across the country. And right away, you can see from this map that minerals are not spread out evenly at all. Look at how things like coal and metallic minerals are all packed into these older rock formations, especially over in the Chota Nagpur Plateau. And then you look at the huge plains of northern India, and it's pretty much a mineral desert. The distribution is incredibly uneven. Let's take just one example, bauxite, the stuff we get aluminum from. I mean, look at this breakdown. It's kind of wild. Just one state, Odisha, is responsible for a whopping 65% of the entire country's supply. Think about that. It means the good stuff, the jobs, the money, and the bad stuff, the environmental impact of an entire industry, are all focused on this one region. Okay, here's a cool little fact that really puts things into perspective for you. For every single ton of steel we make, the foundation of our buildings, our cars, our bridges, you need about 10 kilograms of manganese. It's this tiny but absolutely vital ingredient that most of us never even think about. You want a fun history fact? This one really shows you how much our values can change. Back when aluminum was first discovered, it was way more valuable than gold. So much so that Emperor Napoleon III in France would serve his most important guests with aluminum utensils. The less important guests, they had to make do with boring old gold and silver. Can you even imagine that? Gold was for the B-list guests. But all this stuff we're digging up, it comes at a price, because getting these minerals out of the ground, well, it has a pretty dark side. And that brings us to the really serious reality of mining. And these two pictures really show you the two sides of that coin. On one side, you've got the immense scale of a mine, where the entire landscape is just being torn up and remade. And then on the other side, you see the direct result, a truck kicking up this massive cloud of dust, polluting the air for the miners and anyone who lives nearby. The dangers here they're serious, and they come in a lot of different forms.
For the miners, there's the constant threat of lung disease from breathing in all that dust, not to mention the risk of the mine itself collapsing or catching fire. And for the environment, you're talking about poisoned water, wrecked soil, polluted rivers, the list goes on. And in some places, you get these incredibly dangerous, illegal operations like rat hole mining, which is just a massive threat to people and the local ecosystem.
So these challenges with mining, they really open up a much bigger conversation about our planet's resources, especially when we talk about that third big category, energy. And this is where we're facing a huge dilemma about our future.
The choice we have is pretty straightforward, but it's also one of the most important we'll ever make. On one side, you have our conventional energy sources, like coal and oil. The key thing here is they are finite. There's only so much of them in the ground, and when they're gone, that's it. They're gone. On the other side, you've got non-conventional sources, solar, wind, tidal power. These are renewable. They tap into the power of nature, and they offer a way to a more sustainable future. And this map of India's energy really drives home a problem that a lot of countries are facing. The economy is still overwhelmingly powered by these conventional, non-renewable sources, the huge coal fields and oil reserves you see here. This is what's powering the economy right now, but the fuel tank is running low.
So we've got a really clear problem, right? We have a limited supply of this stuff, but our demand for it just keeps going up and up. That really only leaves us one logical way forward. We have to get serious about conservation and sustainability.
So what does that actually look like in practice? Well, first, we have to be a whole lot smarter about how we use what we have, planning things out sustainably. We also need better tech so we can use lower quality ores that we used to just throw away. And this is a big one. We have to get way better at recycling and reusing metals. And of course, the most important step, we have to go all in on shifting to renewable energy.
You know, it all boils down to this one simple but really powerful idea. Energy saved is energy produced. It's the core of everything. Every single time we save energy, whether it's by turning off a light or choosing a more efficient car, we are effectively producing more energy for the system. It's literally the cleanest, cheapest energy there is.
So we've gone on this whole journey from the inside of a toothpaste tube to the high price of mining and the huge choices we have to make about energy. So I'll leave you with this question. After seeing this hidden world all around us, what everyday object are you going to look at differently tomorrow?